Hello friends, I welcome you in lecture number 2 on F distribution. In lecture number 1, we have introduced what is F distribution and how it is defined, and we have seen that the probability density curve of F distribution is similar to the probability density curve of chi-square distribution. It is having a right tail, or it is skewed towards the right side. It is having a long right tail. Now here we are going to understand that how to find out critical values for F distribution. As we have discussed in last lecture, that because F distribution is defined as ratio of two chi-square random variables, all the values of F distribution are always non-negative. And here it is clear that graph of this density curve is not symmetrical, it is asymmetrical. So we are going to use F table exactly same in the case of chi-square table. In chi-square critical values, we require degrees of freedom and level of significance. So here also we will require level of significance, but because this F distribution is defined as ratio of two chi-square independent random variables, we have numerator degrees of freedom denoted by nu1 and denominator degrees of freedom denoted by nu2, or some sources write this as degrees of freedom for numerator as df1 and df2 is the notation for degrees of freedom in the denominator. To use F table, we will require level of significance alpha, numerator degrees of freedom and denominator degrees of freedom. Now suppose we are interested in calculating the critical value of F such that this area to the right of that F value is alpha, then this point or this critical value of F is denoted by F suffix alpha. Or we can say that if we are interested in the probability that F takes values bigger than this F alpha, then this probability is alpha. That is, we can say that right tail probability is alpha, or area to the right of this point is alpha. So if I am interested in finding this critical value, I will require degrees of freedom and I will require value of alpha, and then I will look in the F table to decide this point. So first we understand how to find out this critical value of F alpha such that area to the right of this point is alpha. And again I repeat, this is the graph of F distribution. This F alpha is the critical value of F such that probability that F is bigger than F alpha is alpha, or in other words, area to the right of this point is alpha. And now we are discussing how to find out values of F corresponding to right tail probability of alpha. So suppose we consider alpha equal to say 0.05. Suppose level of significance is given as 5%, so that alpha is 0.05. Suppose we consider numerator degrees of freedom equal to 5 and denominator degrees of freedom equal to 10, and we are interested in the right tail probability of alpha. So approximately we roughly sketch the graph of F density curve. It is asymmetrical, having a right tail, and because alpha is 0.05 and we are considering probability towards the right tail, this area is 0.05 and this critical value of F will be denoted by F suffix 0.05. Now in the F table we will be given this type of things. Here we will have numerator degrees of freedom, these column headings, and this left column will be denominator degrees of freedom, and we will have these tables for different values of alpha. This whole table will be for say 5% level of significance. Similarly, we will have another table for 1% level of significance, and so on. So this you have to see the title of your table, that whether it is for 5% level of significance or 1% level of significance. First you have to decide that corresponding table for given values of alpha. I am showing you here in this table. This is F distribution table, critical values of F, and here you can see, here it is written that these critical values are for 1% significance level. That is, if you are interested in the value of F critical value for alpha equal to 0.01, then all these values are for alpha equal to 0.01 level of significance. Similarly, here all these values are also 1% level of significance. You can see these values are for numerator degrees of freedom, and these values are for denominator degrees of freedom. Here numerator degrees of freedom are up to 20, therefore they have given another table for numerator degrees of freedom from 25 to 200, and similarly this is for 0.1% level of significance, that is alpha equal to 0.001 value. So in short, you have to first decide what is your level of significance, and you have to find out that F table corresponding to that level of significance. If your level of significance is 1%, then we will use this table depending on this value of nu1 and nu2. Suppose value of nu1 is less than 25, then we will go for this table. And here also all these values are for alpha equal to 0.05 level of significance, and remember that these critical values are for right tail probabilities only. Whenever I say that all these values are for F distribution value for F alpha, all these values are these critical values denoted by F alpha. That means all these values are those points F alpha such that area to the right is equal to alpha. So there are no left tail critical values are given. These critical values always corresponds to right tail probabilities, and these are also for 5% level of significance. Alpha is 0.05. Here numerator degrees of freedom are up to 1 to 20, and denominator degrees of freedom are up to 1000. All the values are not given. You can see here there are 35, then 40, 50, 60, 70. Some values are given. Starting values are in continuous range up to 15 and 20, 21. You can see up to 30 they are including all the integers, but after 30 they are considering 35, then gap of 5, and so on. Same thing here. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now there is a gap 12, then 14, 16, 20, 18 and 20. Now we are interested in the F critical value for alpha equal to 0.05 and with numerator degrees of 5 and denominator degrees of 10. So first I will search for alpha equal to 0.05 table, and then I will search for 5 and 10 in the numerator and denominator degrees of freedom. So here you can see this table is for 5% significance level, that is we can use this table. Numerator degrees of freedom are 5 and denominator degrees of freedom are given as 10. So here I can search for 5, and here you can see this is nu2. So I will take intersection of this row and this column, and the point at intersection is our f critical value. So let me remove these two lines now, and my intersecting point is 3.33. This is value of f at alpha equal to 0.05 level of significance for 5 degrees of freedom in the numerator and for 10 degrees of freedom in the denominator. Some sources are using these different notations. This I can write as f suffix 0.05. Numerator degrees of freedom are 5 and denominator degrees of freedom are 10, and this I find as 3.33. These are different ways of expressing the same critical value. Some books are using this notation also. They write in continuous way. First they write level of significance, then numerator degrees of freedom, then denominator degrees of freedom, and you can write in this way also. Some sources are considering small f also. Instead of writing capital F, they write in this way, f suffix 0.05, then numerator degrees of freedom, denominator degrees of freedom, and this we have obtained as 3.33. So you can see here what is this point. This is nothing but 3.33. So in this way we can use f table easily. All we have to take care is, first you find out the f table corresponding to given level of significance, and then you find out table corresponding to numerator and denominator degrees of freedom. We can find out another value also by changing this numerator and denominator degrees of freedom. Suppose we use this table. Suppose we are interested in the critical value f corresponding to numerator degrees of freedom equal to say 60 and denominator degrees of freedom equal to say 29, and level of significance is alpha equal to 5% or 0.05. Then first I will search for these column headings for 60 degrees of freedom, and in this column I have to go up to 29. So I am going down unless I obtain 29. So here I obtain 29. So now I will consider this row, and here I will go down until I obtain that row. We have to take intersection of this column corresponding to 60 degrees of freedom and column corresponding to 29 degrees of freedom, and now we find out point of intersection of these two lines. So let me remove this, and here I obtain my critical value f for alpha equal to 0.05 level of significance, numerator degrees of freedom 60, denominator degrees of freedom 29, and it turns out to be 1.75. So in this way we can find out probabilities corresponding to right tail. These are the critical values of the F distribution for 2.5% level of significance or alpha equal to 0.05. So all these values are for numerator degrees of freedom. All these values are for denominator degrees of freedom. Now how to find out probabilities corresponding to left tail probability of alpha? Because F distribution is not giving us the values such that area to the left of critical point is alpha. F distribution is only for those values of alpha such that area to the right of F alpha is alpha. Now suppose I am interested in this point on horizontal axis such that area to the right of this point is alpha. Then how to find out this critical value of capital F? Here we have 0. So here we are going to use this same logic which we have used in chi-square distribution table. We denote this point by f suffix some quantity such that area to the right side of this point is that quantity. Now it is given that area to the left side of this quantity, this point is alpha, and we know that total area under probability density curve is always 1. Therefore, area to the right side of this point is 1 minus alpha. So this we can denote by f suffix 1 minus alpha. So we are interested in this point f suffix 1 minus alpha such that probability that f is greater than f1 minus alpha is equal to 1 minus alpha. This area is 1 minus alpha. Total of these two areas to the left and areas to the right must be 1, and therefore this area to the right is 1 minus alpha. Now how to find out this critical value which corresponds to this point f suffix 1 minus alpha for nu1 degrees of freedom and nu2 degrees of freedom. So for this type of left tail probabilities we will use this identity. This we will find as reciprocal of this critical value. We will find out critical value of f corresponding to this right tail probability of alpha, and here we will change the order. Here first degrees of freedom are for numerator, so here we will write denominator degrees of freedom and numerator degrees of freedom. Remember this identity, it is very important whenever we are interested in the left tail probability of alpha. We will use this identity f suffix 1 minus alpha for nu1 and nu2 degrees of freedom equal to 1 divided by f suffix alpha for nu2 and nu1 degrees of freedom. For example, suppose we consider that left tail probability is 0.05. Let me roughly sketch this curve. Suppose this is the probability density curve for some degrees of freedom, and suppose this probability is 0.05. This is alpha equal to say 0.05, and therefore because this area to the left side is 0.05, area to the right side will be equal to 1 minus 0.05, that is 0.95. So this point will be denoted by f suffix 0.95, and suppose numerator degrees of freedom are 4 and denominator degrees of freedom are say 11, and we are interested in this critical value f suffix 0.95 with 4 and 11 degrees of freedom in the numerator and denominator. So you can see here, using this identity, I have to write this as reciprocal of what is alpha. Alpha is 0.05, this is 1 minus alpha. So here I will consider f suffix 0.05 and I will interchange degrees of freedom. Here first degrees of freedom are 4, so I will write 4 as denominator degrees of freedom, and I will replace numerator degrees of freedom to, I will replace denominator degrees of freedom to numerator degrees of freedom. In short, I will interchange numerator and denominator degrees of freedom, and I will search for this value in the table and I will take reciprocal of this. So now I have to search for 5% level of significance and for 11 and 4. So here these are the values starting from 25. So I have to go here. These are the values for 5% level of significance, and we have to search for given numerator and denominator degrees of freedom. So here nu1 is 11, nu2 is 4. Nu1 is not given here. You can see new one is for 10 and 12. And what is new 2? New 2 is 4. So new 2 is 4, so that means we are interested in this line. But for 11 we are not having values. Numerator degrees of freedom for 11 are not given in this table. So what we can do, we can find out average of degrees of freedom corresponding to these two values, and nu 2 equal to 4 is given. So now we will search for these two intersections. Because I am not having nu 1 equal to 11, I will take values corresponding to nu 1 equal to 10 and nu 1 equal to 12, and for this nu 2 equal to 4, and I will take their intersection and then I will find out their average. So this is 5.96, this is 5.91. I have found these two intersecting points, and let me remove this. So I will consider my value as average of these two, 5.96 plus 5.91 divided by 2, and let me calculate this. 5.96 plus 5.91 equal to divided by 2, and I find that this is equal to 5.935. So this will be my value here, 5.935, and here I am using 1 divided by 5.935, and this turns out to be 0.1685. So this point is nothing but 0.1685, such that left tail probability is 0.05. So this is the way how we can find out left tail probabilities, and remember this relationship. And whenever you are not given degrees of freedom for particular number, here we were not given degrees of freedom for 11, so I have taken two nearest numbers for 11. 10 and 12 are nearest number or are in the neighborhood of 11, so I am finding these values corresponding to 10 and 12, and then I take their average. Now suppose we are interested in the two tail probabilities, that is we have level of significance alpha, and suppose our hypothesis test is a two-tailed test. So in that case we are dividing given value of significance into two equal values, and then we find out corresponding probabilities. So that is also similar to chi-square distribution, but let me explain again for F distribution. So here also we have same procedure. Let me roughly sketch the graph of chi-square distribution. We always have right tail towards the positive side. Suppose these two areas are equal to alpha by 2. Suppose we have two-tailed test and we want to find out these critical points. This area is say alpha, and suppose we are considering alpha equal to 0.05. Therefore alpha by 2 will be equal to 0.025. Therefore these two areas are 0.025. We are dividing them into two equal areas. Now area to the right side of this point is 0.025, so I denote it by F suffix 0.025, and I have to find out area to the right side of this point. So for that I am considering 1 minus area to the left side of this point, and that turns out to be F suffix 0.975, and these values of F are on horizontal axis. So I have to decide what are the numerator and denominator degrees of freedom. Suppose we consider nu1 equal to say 4 and then nu2 equal to say 10. And here level of significance, for table we have to use this value as level of significance. We have to consider the area to the right side of this point as level of significance while using F distribution table. Here alpha is 0.05, but we will not use F table for 0.05. We will use F table for 0.025 level of significance, because we are dividing this into two equal areas such that area to the right side of this point is 0.025. So I have to search for this F table. These are the critical values of F distribution for alpha equal to 0.025, and what are the numerator and denominator degrees of freedom. So numerator degrees of freedom are 4, denominator degrees of freedom are 10. So here I am searching for numerator degrees of freedom equal to 4, denominator degrees of freedom are 10, and we find out intersection of these two lines. Let me sketch clearly. So I am interested in the point of intersection of these two lines. So let me remove this 2, and I have 4.4683. So that is my this critical value, 4.4683. 4.4683, and this we can denote by this notation also. We are using 0.025 level of significance. Numerator degrees of freedom are 4, denominator degrees of freedom are 10. Now what about this point? So because we have area to the left side of this point is 0.05, we will use this identity f1 suffix 0.025. This we can write as f suffix 0.975, and I want to use that identity. Remember this identity, f suffix 1 minus alpha with numerator degrees of freedom nu1 and denominator degrees of freedom nu2 equal to f suffix alpha, and interchange these two. So here I have nu2 and nu1, and this I will find using F table, because F tables are given for right tail probabilities only. This is equal to f suffix 0.025. Here numerator degrees of freedom are 4, denominator degrees of freedom are 10. So here we will interchange them, 10 and 4. I am interchanging these two. And now I will use F table for 2.5% level of significance with numerator degrees of freedom equal to 10 and denominator degrees of freedom equal to 4. So here now I have to search for numerator degrees of freedom equal to 10. So I am looking here. This is for numerator degrees of freedom 10, and what are the denominator degrees of freedom? 4. So 10 and 4, and I have to take intersecting point of these two, and we can see it is very simple. I am finding intersecting point of lines corresponding to nu1 equal to 10 and nu2 equal to 4, and it is 8.8439. What we have obtained? We have obtained critical value of f for alpha equal to 0.025, numerator degrees of freedom 10, denominator degrees of freedom 4, and it is 8.8439. So that I will write here 8.8439, and now I am taking division of these two, 1 divided by 8.8439, and using my calculator I find this as 0.1131. So this point is 0.1131. So in this way we can use this F distribution table, and all we have to remember is that critical values of F distribution are always given for right tail probabilities. So whenever we are interested in the left tail probability, we will use this relationship, that F suffix 1 minus alpha with nu1 and nu2 degrees of freedom equal to F suffix alpha for nu2 and nu1 degrees of freedom. And rest of the process I have explained here. I hope you will be able to understand this. If you have any doubts, you can ask in comment section. Thanks.